All right, so we are recording. Good morning, my name is Bear Shea. I'm the Mental Health and School Counseling Specialist for the DOE. And this session is from our Trauma-Informed Response and Readiness Conference that we had been running that has now been moved remotely. So this session, part of that Readiness and Response workshop was delivering some of the foundational elements, and one of those is Brain 101. So this presentation was really designed to be sort of a take-home session and for schools to be able to take this information and these presentations and be able to present them, at their school with their staff in a way that makes sense. So it wasn't so much about just recording me and having me present it, but actually taking this information and then representing it in a way that is most authentic for your setting in your school. So hopefully I'll give you this information, and then you can also find these resources, including hopefully this video soon, but links to this presentation as well as presenter notes. So I'm gonna go through it. The idea is for this presentation only to be 30 or 40 minutes and to be pretty quick. I'll probably spend a little time just expanding on some of these areas more than I normally would because we have a little bit of time and I thought it would be a good resource. This will cover brain, it will cover stress, it will cover survival, and it's gonna cover some ACEs as well. My background, I'm a clinical social worker, and I've really, brain science is something I sort of get really geeky about. It's always fascinated me, and really in the past 5 years or so, there's been so much new information. So a lot of this is things that I've had to change because we keep getting new and new info. So hopefully, this will be as up to date as possible, and I'll be updating this as new information comes out. So I'm gonna just jump in a little bit. Again, if you have questions, you can post them in the chat and I'll try to answer them at the end of this. But largely this is just sort of designed to be sort of just run as a presentation. So, so let's jump in. So brain, again, the past 10, 15 years, there's been a lot of new information. And then really the past 5 years, we've been able just to see deeper into the brain and the way it works and its systems. We've had lots of different ways of looking at the brain, comparing it to a computer, comparing it to highways. Sort of the metaphors never end. And the interesting piece is that because the brain is such a complex system, there really aren't very good metaphors to use because we can't even come close to counting all of the neural connections. There's more neural connections than stars in the universe, in the entire universe. So, that ability of understanding is just out of our grasp. And that being said, a lot of this presentation is really presenting really complex ideas in a really simple way. And so I hope for a lot of science teachers out there and, and other people who are in this field, hopefully you sort of appreciate that I'm really trying to present these in simplistic terms and with simple systems. So these really do have larger pieces, but the idea is to get the information across and just build that understanding of trauma-informed practice. So when we think about the brain, really I'm just going to focus on 3 systems. I'm going to talk about the prefrontal cortex, which is right here. If you put your hands on the flat of your forehead here, like you're taking your temperature, that's where your prefrontal cortex is. That's where you are. That's where our whole sort of idea of self and our ability to think and have rational thought all exists in that prefrontal cortex. This really exists only in some animals. The highly developed prefrontal cortex that we have as humans is quite unique. There are a few other animals that have it, but the ability to think and to plan and to problem solve, building tools and these sort of really large multi-step processes comes from that prefrontal cortex. The other significant piece we're going to talk about is the hindbrain. And if you sort of take the webbing of your hand, your thumb and your forefinger, and you turn your hand upside down and you put it on the back of your head, like you're sort of massaging the back of your neck, you can feel there's sort of 2 knobs at the bottom of your skull. And that's where your spine connects into the bottom of your skull. And that's where your hindbrain sits. If you actually, it's sort of an interesting piece. If you put one hand on your forehead and the other hand back here on that space, you can actually get these sort of interesting tingly feelings. Don't squeeze, but just by like drawing attention to those areas, you're actually sort of engaging them a little bit, and you can actually get some feeling from them. The hindbrain is really fascinating. All animals have hindbrains, and that's where our survival systems live. It's where our basic systems, breathing, and our automatic functions, but then all animals have a survival system, and that's where our instincts are. That's where our ability to survive comes from. And note that that piece is connected right to our spinal cord, so it's as close as it can be to the rest of our physiological systems. And there's a reason for that. It wants to be as efficient as possible and to be able to get our body into a survival state as quickly as possible. So another good way to think about that is Dan Siegel has developed a brain model, and I'm sure some of you have seen it, but the idea, you sort of take your hand, tuck your thumb into the center of your palm, and then fold your fingers over. And this sort of looks like a brain. So here's your prefrontal cortex. Your hindbrain sits on top of your spinal column that goes down. And then the third part of the brain that we're going to be talking about a lot today is the amygdala. That's this little guy that gets tucked inside, sort of in that core part of our brain. And the amygdala is really an alarm system that we use. One sec, I'm going to jump down to that slide. So the amygdala is the alarm system for the brain. It's something that we use to begin to, it sort of assesses threat. It's on constant high alert. It's on constant alert. And so the way that it operates with the prefrontal cortex and the hindbrain is going to really come into play, and we're going to talk about that probably the most today. A couple other things I want to get to before we get there is wire and fire. So this is the idea. We have trillions of connections. Well, we have billions of actual cells in our brain, those neurons that sort of are this electrical system. And then each of those neurons can be connected to multiple other neurons and just create trillions of these connections. And the way the brain works is really to build efficient systems. It wants to create the shortest path from one thing to another so that it can get the result it wants. And so if we think about it, the first time somebody picks up a basketball and goes to throw it towards the net, the brain has to do all of these different things to try to figure out, okay, I need to be standing this way, and I need to be able to lift the arm. I need to be able to sort of figure out what the path is, take into account how heavy this ball is, how hard I have to throw it, how much energy I have to put into that muscle to be able to move it in that way. So all of those things, and if you were to sort of look at the brain and how it did it, it would sort of scatter plot and hit all of these different neurons, boom, 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 boom. It'd sort of be all over the place. The reason that we practice things is that practice actually starts to show the brain that there can be a path that isn't all over the place, but actually the brain will start to trim out and find the most efficient way. And as we practice more and more and more, the brain will actually continue to ride that. It will wire all those neurons together so that there is a more automatic response. And we know that, professional athletes, artists, craftsmen, any of us that are doing work that we've done over and over and over again, we're not thinking about it anymore, right? So a professional basketball player, when they go to shoot a free throw, they're not tracking all of these different pieces that they have to do. Their brain isn't tracking it. It's jumping on at one spot, knowing that this highway that's been created is going to lead to this other side. And so that's how efficient our brains can be. And that's why we talk about the brain being a plastic system, in that our brain, those connections, those neural connections can move all over our brain, which means that if there's a space that's damaged, we can build a highway around that damaged piece and still get back to that other place. And then that learning piece really gives us this incredible capacity to change systems, even though they are wired together. It also means that when things sort of happen and they are related to the highway system, the brain can just jump on that highway system and go in a seemingly automatic way. And so that's something we're going to talk about a lot more too. And one last piece with that, the brain has this amazing ability to generalize. So even though a professional basketball player, knows the weight of the ball, and when they go to throw that shot, they're getting on that part, that superhighway, and sort of running down it in an automatic fashion. But the brain has the ability to generalize so that if they picked up, a paper ball and went to throw it into a trash can, even though the weight is different and the shape and all of these factors are really different than a basketball, their brain has the ability to connect to that wire and fire highway and take enough information out of it to be able to make that shot far better than those people who hadn't practiced as extensively. So that's the beauty of the wire and fire part of our brain. It's also one of the things that can lock us into some of our survival responses. So we're going to talk about that more. This next slide I actually tend to avoid because it's something I could talk about for hours. Mirror neurons are so fascinating, and we're getting more and more information about them all the time. It really does come into play, particularly with our amygdala and the way that we are assessing situations. And so I'll talk about that more as we go forward, but sort of the base idea is that we have specific neurons that are designed to mirror and replicate what other people are doing. So while I'm talking and you're watching this video, if you see my hands are moving, there's a little you inside your head that is doing the exact same motions that I am doing. And so those mirror neurons aren't replicating me, they're actually replicating you doing these same motions. And what that's doing is it's sending that information back. So I'm like in your head right now, which is interesting. And anytime we're sitting with somebody, all of those body movements, all of the, all the micro expressions in our face, all those things are being replicated by these mirror neurons, and that information is being sent back into our brains for it to be assessed. And whether that information is being assessed by our prefrontal cortex or our hindbrain really starts to come into play on how we're viewing those motions. So and again, see, I have to cut this slide down because it's something I could talk about forever. We'll talk more about mirror neurons, particularly with stress and survival. So cover the amygdala. So that emergency center in the center of the brain, that amygdala, it's taking into account all of the information that's coming in around us, and then it's going to send a signal out to decide where the threat is. When that happens, we get into an interesting space where the amygdala decides to send out a threat, and then it really comes down to the efficient response from the brain. So I use this metaphor a lot because it sort of helps sort of take into account some threat without there being a lot of safety concerns. So if you're standing out in a field and you hear the, sort of a crack of a bat, and you look over to the side and there's, sort of this ball hurtling towards you, your prefrontal cortex is going to look up and be like, oh, there's a sphere. It's rotating anti-clockwise and it's got red laces on it. And it's got this really nice parabola arc. Oh, it probably started over here. And look, it's starting to head in this direction. And by the time our prefrontal cortex said, oh, crap, it's going to hit me, it would be too late. Even though that's happening in split seconds, even though our prefrontal cortex still operates in this incredible amount of speed, it might not be fast enough for us to be able to react to it. And so our amygdala picks up that crack of the bat and sends out a signal. And what happens is that signal goes to the hindbrain and says, we're under attack. And the hindbrain has this highly tuned, efficient system. We know that sometimes if we just catch something out of the corner of our eye, that it will jump. It's sort of that two for flinching game that we played as kids, or like, someone like swings their fist and we react. And then for some reason get punched anyway when we react the way we're supposed to. But that hindbrain has the ability to pick up just a tiny amount of information and then react almost instantaneously, as fast as we possibly can react. And the reason that we can react that fast is because the hindbrain turns off the prefrontal cortex. It has the ability to actually shut down the prefrontal cortex so that it's not just standing there trying to think while the hindbrain is acting. And that is really a sort of this developmental piece that has allowed us to survive, because if this part is just sitting there talking and deciding on whether it should act, we probably wouldn't survive. And so we're relying on that hindbrain to do that for us. There have been some really amazing studies, and it's something that you can YouTube, of some of the brain scans where people are actually hooked up to brain scans, and you can sort of see where those neurons are firing. And they're sort of seeing, they have pictures flashed up in front of them of these like beautiful sunsets and fields of flowers and, sort of over and over. And you just see this nice glow running through the brain. And then there's a picture of a dog, like full frothy Cujo attack mode coming right at them. And you can watch the amygdala fire off, and then you can watch the signals get sent into the hindbrain, and then you can just watch this go out. It's like those movies when there's like when there's a power outage and the whole city starts to go dark. That's what happens in our prefrontal cortex. That's where it's basically the brain saying, we don't need to think right now, we need to react. And we're going to rely on the hindbrain. And actually, the prefrontal cortex gets in the way. And so we're just going to shut that down so that we can get through this and survive. That's how the amygdala sends those messages. And that idea of the prefrontal cortex going dark while the hindbrain kicks in, that's going to be the basis of what we're going to be talking about for the most part today. And know that this system and the way that this works isn't just for trauma. You know, I know we're talking about this in a sort of a trauma setting. This is all of our brains, all of the time, for all people. And that there isn't just one sort of specific way of this happening. It isn't just for one specific group of people. This applies across the board. And when we look at, you know, a multi-tiered system of support, you know, we talk about tier 3 and sort of the interventions there, but this is really a system that we should be working on across tier 1, tier 2, and tier 3, because this is for all of us. And it's not just for students, it's us as professionals and how we're handling these stress. And we'll talk about that more as we go forward. I have let's see here. So let's move into survival and the way that it works. So we've talked about survival in the past and how it works. And one of the things that we notice a lot, we hear a lot, are sort of the fight, flight, freeze. And so we're going to talk about those quite a bit. Really, there's 4 forms of survival that all animals use. Fight is the first one. And, you know, if we sit and think for a second, what are some examples of animals that use fight as a survival mechanism? So not as a way of, you know, hunting or you know, or getting food or those things, but using fight as a way to survive, so to protect themselves and to sort of stave off enemies and to continue living, because that's really how survival is working here. And so usually I would take sort of questions from the audience or ideas from the audience. And people talk a lot about like big prey tends to come, big predators tend to come to mind. So people usually say like lions and tigers, and, you know, they put up this ferocious front. And one of the things I usually like to say are, how about like a cornered chihuahua? Right? Like, it's not usually something you would consider as a ferocious beast, but if you've ever seen a chihuahua in like full on attack mode when it gets cornered, you know, that display, it sort of doesn't make a difference, the size of it. It's that it's putting on a display that is so nasty that you don't want to put your hand anywhere near it, no matter how adorable it was before that. And so that's what fight does. It can literally be, I'm going to attack you, but fight can also be that display of, you're not going to mess with me because look how tough I am. And it works for that chihuahua, right? Like, you're probably not going to pet that chihuahua when it's in that mode. And so that's how fight can work. When we move over to flight, think of some animals that, you know, use flight as a method of survival. And I usually love this part of presentation speak, because people usually say birds, which, you know, is sort of that link in our brain of like flight, bird, which is great because birds do use flight as a survival method, literally to get up and fly away. But really running to escape, getting yourself out of a situation is one of those survival mechanisms that has worked for lots of different animals. You know, I put the Roadrunner on here because it's a really good example of being so fast that no amount of rocket blasts or Acme gadgets can catch the Roadrunner. And so it's managed to survive because of that. And if we think of other animals, you know, one of the classic ones, you know, we hear are, you know, deer or zebras or gazelle or any herd animal that you know, uses flight to get away from a predator and uses those numbers as part of that flight to sort of distract. And flight is a really useful survival mechanism when it works. And I think that's what we'll talk about all of these, is that not all survival mechanisms work in all situations. But that's how fight and flight work. So fight is putting up that front or actually fighting to ward off an enemy. And flight is getting out of that situation. And when we put those together, when we think about how the brain works for fight or flight, you know, we're really thinking about a physiological response. So when the amygdala fires off, accesses the hindbrain, prefrontal cortex starts to go dark, Fight or flight gives us the ability, so we want more energy into our muscles. So we're going to access a whole different system of brain chemicals and functions that are going to rush into our system when we move into fight or flight. We know some of the symptoms are increased heart rate, adrenaline gets released, cortisol gets released. The adrenaline helps our heart rate increase and pushes that blood out into our extremities. It gives it more oxygen, which gives more strength to our muscles, which allows us to fight or run. Our body also starts to shut down functions that aren't necessary. So the really interesting part is our brain basically says, not only do we not need the prefrontal cortex, but we don't need all of these other systems. If we're going to survive through this moment, then we can just turn all of those other systems off and take the energy from them and put them into surviving. So our metabolism gets shut down. Why are we going to waste energy digesting food if we're going to die in the next minute, right? So we're going to take that energy and put it somewhere else. We're going to shut down our fertility system. We're going to shut down any of these other parts that normally would be part of our normal everyday processing. And we're going to take all of that energy and we're going to focus it into surviving, into fight or flight. And so as those other chemicals get released, those parts are actually shutting down core parts of our body in order to get through. That's how fight or flight works. We know that like tensing muscles is another sort of an example of when people are starting to go into fight or flight. Quickened breathing up in the chest, sort of that hyperventilating almost. Face flushing because the blood is rushing. So all of those are really symptoms of that fight or flight system. Now, there's two other survival systems. And if we imagine it as two sides of the coin, fight or flight is on one side, and then these next two are going to be the other. And so we get to freeze. So fight, flight, freeze are the ones we've talked about for a long time. Freeze is really the idea that if I can't fight something and I can't run away, I'm going to shut down my system so that it looks like I'm not here. And if I'm not here, maybe they'll leave me alone. So I'm going to freeze and lock down. And so if we think of animals that use freeze as a successful survival mechanism, there's lots of really good ones. I think, I don't know if you've seen the videos of the fainting goats. If you haven't, look it up, just YouTube fainting goats, because it will just, it is the strangest thing. We've bred these goats in a way that we've sort of accidentally triggered this survival response in these poor goats, where if they get spooked, they go into their brain goes into a freeze mode, and it actually locks up their poor little limbs, and they just go and like fall over, and then they take a couple seconds and their body comes back to normal. But it's a really good example of that freeze piece and how powerful it is at a like sort of a neurological brain level. So another one that to me makes perfect sense for us in Maine is deer. Deer use freeze as a way to survive. And the reason, we know that deer are really fast and they can run away, but the reason that they immediately go into that freeze mode is that their main predator, sort of wolves, and then now dogs and other animals that are also fast. The problem is they can outrun wolves in the short term, but a pack of wolves will run a deer down, which means they'll just incessantly go after that deer until it runs out of energy. And so flight doesn't work really well in that situation. And so deer have evolved this freeze mechanism, which allows them to blend in with their background and to hopefully just sort of ride something out. And so that idea of being able to freeze and lock down so that you're not moving, you're not, your whole system is changing in that survival method. And I'll talk about a little bit more about what that looks like, but that's freeze. So that's the idea of freeze. If we move over to the fourth one, now this is an area that's relatively new, that's come out with a lot of the new brain research, and this is submit. And so submit is the fourth method of survival. And submit really is the idea that we're going to give in to something in the short term so that we can survive it. So we're going to sort of give in and do whatever we can to get through so that we make it through to the other side. And if we think about animals, there are a few animals that use submit in a really, really good way. It's oftentimes in freeze when I ask for animals, people say possum. And I usually have to say, like, hold on to that one for the next one. Because yes, while it looks like possums are freezing, what they're actually doing, and we call it playing dead, but they are submitting, right? Not only are they sort of rolling over and looking like they're dead, but their whole system changes. They release a smell that smells like a dead animal. They their tongue sort of lolls out, and they don't move to the point where a predator isn't interested in them because they smell like they're already dead. And then so the predator leaves them alone. So they sort of submit in that just to get through. They're putting themselves at total risk in that way. Some other good examples are, when we talk about dogs submitting to alphas, right? Like a dog will roll over on its back and bare its throat. And what that does is that it, when it shows its throat, it's actually submitting to those animals. And so that's a really good way of showing submit. Another one is if you've ever been to like Yosemite Park and you are talking about like grizzly bears. With a grizzly bear, you can't fight a grizzly bear. You can't outrun it because they can climb trees, and they're really fast. Freezing isn't going to work, and so they recommend submit as a way of surviving through a grizzly attack. And what that means is that you're going to roll over and curl up into a ball, and basically just pretend to be dead, so that when that bear bats you around, it gets bored and leaves, and it doesn't feel threatened, so it just leaves you alone. When we think about submit with people, it sort of starts to make sense where, we can imagine some of the worst things that happen to people, and that it's very rare that we can sort of fight or run away if we get caught. And so submitting ends up being the way to get through and surviving. So these 4 survival methods, fight, flight, freeze, and submit, end up being the core of how all animals survive. And the interesting piece is when you look at freeze and submit together as sort of the other side of that coin, it's an opposite body reaction. So again, the amygdala fires, sends the message back, prefrontal cortex starts to go off, and that hindbrain starts to fire and decide to move into freeze or submit. And so new brain chemicals are released, and those chemicals, instead of like fight or flight where the heart pushes blood out, this is actually blood comes in from the extremities. It actually pools around our organs to protect them. So that if we were pummeled, there's actually some extra padding around our main organs. All of our other systems still get shut down the same way as fight or flight. And because again, we're trying to use that energy to survive. So some of the symptoms are, some of the things that we're going to notice are actually tingling feelings in our extremities, because our blood is actually moving away from our extremities, and sort of that sort of pulling in. It seems like all of that energy is getting pulled in, sometimes even physically getting pulled in on the shoulders, and and you can almost watch somebody shut down and sort of pull in. The gaze gets lowered. Those are all examples of freeze or submit. And so those 4 survival methods are sort of the key for everybody. When you take them all into account, you can start to get an idea of how our brains work as a system. And this is a method that I use, that I've used in clinical work with individuals, where I've talked about how sort of the brain works. I've talked about with students in classes. I've talked about, in whole districts and trainings, that this is a really simple way of sort of looking at where someone's brain is at. And we can think about it for ourselves. And then as we sort of develop it, we can start to think about how that might work with students that we work with, or sometimes each other. So if you imagine the whole brain, that sort of purple spot right there, that's really where our whole brain is online. So it's not that things are good. It's not that, things are happy. Really, that's just we're at our best, right? We have our prefrontal cortex on, our hindbrain on. And when something happens, we have all of those systems to evaluate. Right. So, if I'm going to cross the street and I'm only using my hindbrain might just be in a space where it's like, look, it's not safe to cross the street. We could get hit by a car, so we're not going to do it. Right. If I'm only in my prefrontal cortex is like, hey, I got to go do this other thing. And, cars don't come very often, and da, 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 da. And you're just going to walk across the street without thinking about whether there are cars or not. Right. So if those 2 systems are on either side, then they're not useful. They're only useful in really specific cases. So having our whole brains online means that we can evaluate threat. So if I'm going across the street, my hindbrain says, oh, there's a car coming, watch out. And my prefrontal cortex says, oh, yep, there it goes. And there's a gap in between these 2 cars that should allow me to cross the street without this other car coming. And so having those full systems online really is putting us at our best. When we go into those survival modes and our brain starts to dysregulate a little bit, if we go into fight or flight, if we imagine that on a scale of 1 to 10, and if we go into freeze or submit, we can use a scale of -1 to -10. It's not that either of those numbers are, sort of better or worse. The scales are really just a way of measuring both sides of the coin. And what can happen is that our brains are used to operating under certain survival methods. So, my amygdala fires off and sees threat. My hindbrain kicks in, and maybe I'm the kind of person that uses fight or flight more often. And so I'm sort of maybe already amped up and ready to go and ready to see how things are going in that fight or flight space. Some of us are more keyed to using freeze or submit. It's the thing that has been most successful for us in the sort of situations that we've grown up in. And so the way the brain sort of wires and fires and starts to align us in either of those, we can think of students that we've had where the response is usually in a fight or flight space. And we can think of students that we've had where it's usually more in a freeze or submit space. And as educators, we're really trained and taught to work with the kids in fight or flight. We talk about de-escalation a lot, and we talk about, how we're going to meet kids where they're at with all of this energy and work to get them down into a regulated space. The thing that's happened a lot is that we've been taught to do that, and we've sort of missed the other side of the coin. So if you think about, a student who's in sort of that hyped up energy, maybe they're normally at a 3, and maybe something was going on at home or happened over the weekend. And so maybe they're coming into our classrooms at a 4 or a 5, just walking in the door. And so we're noticing they're a little more edgy and amped up. And then we go to ask them to do something that maybe they would normally do without any problem, or maybe just a little bit of problem. And we get this huge reaction, right? They go from like a 3 to a 4, and then that 4 goes to a 6. And it's this reaction that doesn't make a lot of sense because, we're just asking them to do this small thing. Maybe it's like pushing in a chair or putting their backpack away. And it's something that normally is something that they're usually doing. And this reaction is so extreme for this really sort of common thing, and it doesn't make sense. And the reason it doesn't make sense is because it literally doesn't make sense, because we're not using that kid is not using their prefrontal cortex in that moment. And so what would rationally be happening for them if their whole brain was online is that they would be able to rationally say, oh, that's not a big deal. The teacher is asking me to do something that I do all the time, even though I have all this other stress and things that are going on. However, if we're dysregulated and we have less or very little of our prefrontal cortex on, that rational piece isn't there. And so our reaction is from this primal hindbrain space that doesn't have a lot of rationality to it. And so when we're seeing things that are irrational, it's because the brain at that point is on fire and there isn't a rational part. And so when we look at it that way, when a kid goes into a 5, a 6, they're less rational, which also means that when we try to use rational arguments or rational redirections to try to pull them back, those rational redirections aren't going to work either. So a lot of the behaviorism we've been taught to use doesn't work in these situations with dysregulated people, because it's not just kids, we get dysregulated too. So the interesting thing, so let's say, I'm working with a student and I get this really big reaction from asking them to put their bag, on the hook. And I'm like, whoa, hey, like, I know this is it seems like it's really tough. Like, I'm going to ask you to sort of settle down a little bit and, why don't you take some space or use some of these other things. And then I just see that go up a notch and go up a notch. And I start to realize like, oh no, this is starting to ramp up. And so a lot of what we've been taught is to ramp up our response. And so, my response is, hey, if you can't get yourself settled down, we're going to need to have a conversation with the principal. We're going to need to spend some time outside of the class. Like, I'm just sort of making up, next steps. And then all of a sudden we see that ratchet up even more. Like, this is even getting more intense. This kid's starting to really dysregulate. So maybe I say, all right, we're going to have a conversation with your parents. And all of a sudden we see that behavior just stop. Right. And they're like, okay, fine. Like, whatever, I'll do whatever, fine. I'll hang up my bag. And they go over and they hang up their bag. And then they go over and they sit down and they take out their worksheet and they start getting to work. Right. And then we're like, oh, look, like, all right, we de-escalated that situation and we got that kid so that they're actually doing their work now and following directions. Ha, excellent. Great. And when we shift our focus to all of the other kids that are going on in our classroom, what's happened for that brain is that sort of threat of hey, I'm telling you to do something, you need to do it, right? So you're reacting to me saying that you need to do your backpack. I'm saying that you need to hang up your backpack. That's coming into the amygdala, and the amygdala is saying, hey, that's threatening. And so I'm going to shift, and I'm going to show you more fight or flight so that you leave me alone, right? More fight. And then I'm saying, oh, you're going to go see the principal. Oh yeah, I'm going to show you even more fight so that you leave me alone, right? And then we say, I'm going to call your parents. And that threat lands in the amygdala like, oh no, that's the worst thing. That's going to get me in way more trouble. In fact, I know that might be really unsafe for me if my parents find out that I'm not, behaving. The messages I'm getting at home and the situation I have at home might be so risky and unsafe that I'm actually going to shift into a different survival mode right now. So in order to stop you from doing that, right, all of my fights didn't work to stop you and to get you to leave me alone. And so I'm going to move into submit. Right. And so I'm going to go from a +6 and I'm going to go into a -6. Right. And so now I'm going to just, okay, fine, I'll do what you say. I'm going to hang up the bag. I'm going to go over and I'm going to get busy on this worksheet. And I'm going to show you that you don't have to call my parents and that you don't have to meet that threat. The thing is that if they were at a +6 and now they're at a -6, they're still dysregulated. Right. Their brain is in the same place as if they continued to be in that fight space. The thing about submit is that it looks like they're fine, but they didn't actually regulate. And maybe over time, maybe some of the routine will help them sort of regulate and come back, but maybe not. Maybe they stay in that freezer submit space. Because anger, like feeling angry, the emotion can exist in fight or flight. It can also exist in freezer submit, right? I can have red hot burning anger, or I can have cold anger that I'm holding onto and just waiting for, right? And so those spaces of fight or flight or freeze or submit, all four of those are really successful survival mechanisms that particularly us as humans might be able to vacillate between. And sometimes it's really hard to tell, particularly when we're not taught to be aware of freeze or submit very often. So something to think about, and using this way of monitoring, where somebody's brain might be at, maybe a helpful way of sort of charting that. It's also a really great way of noticing where we're at as far as, am I in a fight or flight stage? Am I in that sort of like sort of feeling tense? What are the skills that I can use to sort of regulate my brain? Or am I shutting down and stepping away and trying to avoid things in sort of that freeze or submit space? One thing I always say when I do these trainings is don't take this home to your partner and sort of be like, when you get into a conversation later and be like, hey, honey, I notice you're sort of in a 5 right now and maybe you're a little dysregulated. I really would advise against that. Rarely goes over well, but definitely practice it and be aware of where people are at with their brains and be aware of ourselves, particularly that freeze or submit, because we don't get a lot of time and training on it. So I want to jump out of survival and just go into stress. And I know I'm already like 40 minutes deep into this. So I'm going to try to cover stress. I'm going to try to cover the rest of this relatively efficiently. Again, this is something I could do days on. So when we think about stress, there is a certain amount of just relativity, right? So what is stressful for me is going to be really different stressful for you. And that's based on what my experiences are and the way my amygdala sort of assesses threat. And so sometimes like the worst things we can imagine for ourselves are really don't seem to be putting a lot of stress on somebody else in that same situation, and vice versa. Somebody else could be having an extremely large stress survival response from something that seems really not that big of a deal to us. And so that relativity is really important to take into account. We also notice that prefrontal cortex, that development as we get older, starts to actually take into account some of the risk, which is why we see kids doing things that are slightly horrifying to us because we understand the risks because we have a higher, like a more complete developed prefrontal cortex. It's also why there are certain key points developmentally where our brains unpack themselves and they're sort of reorganizing structures based on sort of our brain development. And there's a key one of those in adolescence, which is why we see adolescents having a greater deal of understanding and then all of a sudden a lot less understanding of risk. And so we see them doing things that, again, don't make a lot of sense. And that's because our brains unpack at that age. Perception of stress is also something that's really important. So when that amygdala sees something and perceives it, our experiences go into that, and that sort of wire and fire system is gonna hop on and sort of carry us down. So for most of us, when we see this sort of picture of this like beautiful beach, you know, and sort of this you know, gorgeous landscape and the water, you know, we think of, oh, maybe this is this relaxing thing that I would love to be at right now, right? But some people, when they see this picture, they see this, right? And so that thought, the way the amygdala perceives something ends up becoming a really significant source of can be a source of that stress. And so what seems really nice for some people might seem really awful and terrifying for others. Um, so that idea of a regulated brain, that when we're at our best in neural regulation, that you know, our whole brain is online, that we're able to use our prefrontal cortex to mitigate and to say, nope, that's not a life-threatening thing. You know, sitting down and doing you know, an entire video recorded session and lesson on this that people are going to be able to see and deconstruct, it's really not that stressful. It's not going to be the end. I have to keep telling myself that in my head, right? And that's because I can keep enough of my prefrontal cortex online that I don't just get up and run. So that's the idea, and that's keeping in that regulated space and helping teach kids how to stay in that regulated space and know when their brain is starting to dysregulate. I'm going to skip over functional dysregulation. It's something we could talk about forever, but just know that our culture views certain dysregulated behaviors as a good thing. So perfectionism, workaholics, like people that really, you know, we have sort of quasi-negative terms for them, but they're also celebrated, right? Like people who get in and do the job, they're the ones that are successful. They have this grit and perseverance. It also can be, I'm dysregulated enough that I have to submit in order to do this in a perfect way, right? I have to make sure that this is perfect so that people aren't critiquing me. Or I can just completely disregard all of the critics and get in there and do what I think is right. Those ideas can also be dysregulated responses. You know, and so those are spaces that we should be mindful of. If we have students that are, you know, really focusing on getting something perfect, you know, we're like, oh man, they're trying so hard. And it might be that they're actually so dysregulated, and as dysregulated as some of the kids who are flipping over desks and saying they're not going to do it. It's the same level of dysregulated brain. It just shows in a different way. And in our culture, we tend to reward some of those dysregulated things. Something to think about. I'm going to quickly go through ACEs. It's something that we talk a lot about, and you know, it's fascinating because this study is 20 plus years old at this point, and we are still going back and using it as a way of trying to throw up an alarm signal that this is a significant thing that we should be paying attention to. So the idea of ACEs is that it was a study through Kaiser Permanente, and it really sort of came up with these 10 areas, and that these 10 areas, when we asked adults about them, when we compared the impact of how many of these score out of 10 that they had to what their health situation was now, we noticed that people who had more had a higher ACE score, so had, you know, 1, 2, 3 to 10 ACEs. The more ACEs they had, the more significant impact there was on their physical health. And if we look at these 10 areas, we have areas that are, you know, we have abuse, physical, emotional, sexual, neglect, physical and emotional, and then household dysfunction. So things that are out of our, you know, a lot of these are largely out of our control, but things that happen sort of around us. And obviously there are significantly more than 10 ACEs, but this study just covered these 10. And it very quickly became apparent that the relationship between those 10 and these areas was so significant and outstanding and obvious, that this became a touchstone for a lot of work, particularly around brain research and mental health research, because really all this is showing is a cause and effect, a correlation between having experienced these things and having these effects on us physically. Now, what it doesn't say is that if you have an ACE score of 10, you're going to experiencing these things. Because again, if we go back to that stress relativity, that perception, you know, and honestly, how plastic our brain is and how we're able to, even though we've experienced things that are very difficult and have impacts on us, the plasticity of our brain and our ability to work through those things so that they don't have an ongoing negative impact on our life, so that we're not constantly in those survival modes. You know, those are factors that play into this. And so those are all key things. And also knowing that if we have had these ACE scores in our life, there are ways to reduce the impact on us. And so, this is really what the test came out with. But what it doesn't do is sort of say, okay, we're just going to figure out who has, an ACE score of 3 or better, and then we'll have a treatment modality for them, right? That's not the idea. What it does show is that those of us that have had more ACEs, it can have this impact on us later in life. We know that it's interesting in professional fields, the educational field, we actually have a higher ACE score than a lot of other professions. We also know that 2/3 or more of people have at least one ACE score. And in the MIAS data that just came out, for students, 22% of students had 4 or more ACEs. And so that's a pretty significant amount of impact in their lives to be aware of. And so it's just something to think about. The more, so if we take that back to brain and the way the brain works, if we're having ongoing experience of threat to our amygdala and our systems, that wire and fire piece is saying, I need to survive through this. I need to protect myself. I need to survive. And so that hindbrain is getting into a more automatic space where we're used to having a threat and then developing a response using fight, flight, freeze, or submit, and having a reaction. And so when we've experienced trauma, when we've experienced things that affect us, then our brain is building a response. And if we're constantly getting that message, then we might have an automatic response, or what seems like an automatic response, where our amygdala perceives threat. We jump on that superhighway that's already been built by all of these other things, and we travel down it, and go right into fight or right into flight to freeze or submit. What we know is that the plastic capacity of the brain is that even though that's kind of a seemingly automatic system, we can build in off ramps so that when something happens, we're increasing the ability of staying regulated and showing the brain that it's not actually under threat, and that's allowing more of our prefrontal lobe to stay on longer, and that ability to sort of rationalize and assess and reduce that overall threat can really change our reaction. It's also interesting that it almost doesn't make a difference, in a lot of senses, the survival mechanism we're using as we get older is less and less useful. And so being able to have that conversation and being able to use the prefrontal cortex when we're not in a dysregulated space to assess that can be part of that as well. So I'm already running up on the hour. There's so much information here, and this is such a large and complex system. And I know I haven't really given answers on how to address that. That's because that's a whole other, training. But what this training is really designed to do is to sort of give you the basic understanding and to share that understanding with everybody at your school. The more we build this understanding, the more likely we are to engage in this work and be aware of it. I've been using this metaphor a lot, but we sort of all understand why teaching a child to read is so important. And we sort of agree that that's important as a community, as a culture, as professionals. And so we invest a ton of time into it. We know that teaching someone to read is a really difficult process. It takes multi-years. It takes all of these different intervention styles. It takes, some more individualized treatment. It's something that happens across discipline. But because we all understand that it's important, we do it. If we can get to a point where we're all understanding why these trauma-informed practices and interventions are important for all people, like that this is an ideal way of working with everyone, then it might allow us to start actually doing it. And so this is really designed to build that understanding. So I'm going to jump into the chat and see if I can pull out a few questions in the 10 minutes we have left. I wish I had a little bit more time, and I'm going to be doing some like 201 and, and some other brain pieces since we have this opportunity to do some professional development. So I'd like to do an actual clinical piece moving forward and create some actual like sort of intervention practices. And I'll be working some with content area people in the DOE on presenting, sort of more developmentally appropriate mental health and sort of trauma interventions. So I will be, let me just take a quick look at some of these questions. Just a second to sort of go through here. So this is recorded now. My hope is to work with our IT team and to get this up as soon as possible. We'll put an email blast out when it gets loaded up so that other people are able to watch it. All right, so how do you tell if someone is in submit or if they have regulated themselves? Submit is a really difficult, we don't have a lot of training on it. And so it really is gonna be, so the same way that we're aware of when someone is starting to go into fight or flight, it's really obvious when it's at high levels. Same thing with freeze or submit, it can be really obvious at higher levels. But sort of we get keyed up to what are the signs. We notice the breathing coming up. We know we sort of are trained to sort of see those things. And so some of the things to start thinking about freeze or submit is, are we seeing that pulling in? Are we seeing that shut down? We know that student when they're in a more regulated space, even if they're naturally at like a -3, we can notice when they go from a -3 to a -4 to a -5. And so, you know, that withdrawal, that pulling in, that protective, that eyes turned down, those are all good ways to start doing it. Honestly, just keying our awareness that it's even possible uses those mirror neurons we have to assess other people. So those mirror neurons have a really good job of, like, when I'm looking at someone, the behavior they're doing is being mirrored in my mirror neurons, and that information is being sent back. And if we can sort of attune ourselves to that information, it will give us more of a feeling of that. I'm going to do other things on like how to move in from freeze and submit, how to move in from fight or flight. So I'll do more on that. I definitely don't have enough time now. Let's see what else is going on in here. Yeah, I mean, resiliency, this is the thing, is that resilience studies have been done for 40 years. And the number one thing that keeps coming up is that significant, consistent relationship, right? And that's, as educators, we have the opportunity to be that relationship for kids who don't have it in other spaces. And the more of those relationships they have, right, that consistent relationship with an adult, being somebody that's non-judgmental, being someone that's consistently there, that is still the the number one thing for resiliency for kids, no matter how many awful things are happening in their lives. That's also a weight I know we carry even more now because we don't have that same contact with some of those students. And so working with our administrators to figure out how we're doing that contact in a safe way for them and for ourselves. I'm going to work on getting some of the mental health pieces and some guidance around how to do some of those up on the web as well. Should we leave a student in the submit place? So just like if we were working with a student that was maybe really dysregulated in the fight or flight, sometimes there is like, all right, I'm going to give that brain some space so that it isn't feeling threatened anymore, right? So, you know, if I keep coming at that student in that fight or flight space, their brain is they're not even seeing me anymore. They're sort of seeing this monster with a beard and horns. And so there is an advantage of pulling back and sort of reassessing and letting that dysregulated brain come back, letting more of the prefrontal cortex come on. And if you think about it, that's what fight is trying to do, right? I'm trying to push you away. Freeze or submit is the same thing. I'm trying not to be noticed. You're noticing me right now and you're trying to regulate me. And I don't like that because you're still controlling me, right? It's irrational in a lot of ways. And so sometimes pulling away can create a little bit of space for that kid to regulate. Just like I said, that kid earlier in the example who went to the table and started working, maybe that did take some of the attention off and allowed them to regulate. However, circling back around when that child is in a more regulated space and having those conversations and acknowledging and validating sort of what was going on can be really helpful. All right, what else do I have here for questions? What I would suggest is, you know, obviously there's so much more that goes around this, you know, awareness wise and training wise. If you can work on just building this into your awareness as you're interacting with people all the time, and sort of trying to, you know, when you're having a conversation with someone, trying to say like, are they dysregulated right now? Are they at a +2 or a +3, or are they at a -2, -3? And being aware of it in ourselves, particularly developing awareness, like even just questioning, like, is that person in a freeze or submit space? It will start to create new roads in our brain. It will start to adjust that plasticity for ourselves. It's sort of like practicing whether or not that's there. Like I said, those mirror neurons really help us out a lot. Even if we don't have a lot of specific training in it, we have all of this experience that our mirror neurons have done. So definitely use those as we can. Um, Someone put in a question about manipulating, and manipulation is a really interesting thing. Most kids don't have the ability to manipulate, not the way we do as adults, because the prefrontal cortex is really required to do that manipulative planning in a sort of a calculated way. So when we feel like we're being manipulated, it's often because kids are using those as survival mechanisms to get their needs met, and that there is a dysregulated quality to it. So in order to manipulate, you sort of have to have a lot of prefrontal cortex to do that. And so if you change that ideal a little bit of like that kid's not necessarily manipulating, what they're doing is they're using their survival mechanisms to get their needs met because they're not feeling safe. And so if you look at it as a safety piece, even a kid who's like, I want that toy, and that kid isn't giving me that toy, and so I'm going to go up and punch them, which is fight, right? Or I'm going to go and tell somebody and cry and put on sort of this big display, right? So all of those things end up becoming about safety, even though the safety is about, I don't feel safe if I don't have this thing, which is kind of an interesting idea. And shifting to that, and looking through things at that perspective, like this kid isn't just being a jerk, like their brain is on fire in this situation, that they're in a dysregulated space. And so how do we interact with that? Choices too. Choices are a great way, and it really becomes out of behaviorism. However, if we're dysregulated, choices can seem threatening, right? Because if I'm at like a 5 or a 6 and you're like, well, you can do this or this, right? My brain's like, you know what? I'm not doing either of those because you're trying to control me, and that's threat. So piss off, right? Like we've seen that from kids, right? I've seen it from my own kid, right? Like, hey, I'm going to ask you to do one of these things. And when they're in a more regulated space, even if it's slightly dysregulated, they have enough prefrontal cortex on to know, right? It's also why like timeouts and counting and things like that that come out of behaviorism aren't always successful with dysregulated brains, because if I'm counting, that's like a clock ticking down that's threat, right? So that's about as threatening. And so some kids might switch to a freeze or submit and say, fine, I'm going to do that thing because I know what's going to happen after this is worse, right? And so it works. Threat works really well with kids. It's something that we have used for, hundreds and hundreds of years before we got to this place where we decided that threatening kids and physically hurting kids and physically controlling kids isn't all that great for them, right? And that we'd like to do it in a different way. We haven't really gotten to the place where we've been able to do it in a different way yet. But if we're going to decide that, threat isn't something we want to use, what are the other things that we're going to put in place to still teach and structure and provide safety? If safety is love and structure is safety, then structure is love, and sort of providing that structure for kids in a gentle way, but that still provides structure and safety that allows them to feel like somebody else is in charge. That's part of why those relationships, that one person is a really good connection for resiliency, because there's safety in it, there's consistency in it, and those things are structure and they feel safe. So there's lots of those pieces. I know I'm past the hour now, so I apologize if any of you have to leave. I'm just trying to wrap up any pieces. Just remember, the more dysregulated somebody is, like I know when I've been super dysregulated and someone's like, I think you just calm down a little bit, or why don't you take a breath, right? If I'm really dysregulated, I'm like, oh, really? You want to tell me what to do, huh? Right? That's not actually helpful because I'm not in a rational space. So coming up with other ways of connecting with somebody when they're irrational, sometimes even the ways that we're connecting with somebody might feel irrational ourselves, because we sort of almost have to go there to help bring them back so that we appear safe. I'm sure we've all worked with kids who we have a really difficult time with, and it seems to catch on fire really quick and escalated really quick. But then that student might have a connection with somebody, and when that other adult is there, they somehow magically, that kid will really de-escalate and come down and feel safe and connected. And so they'll have a completely different response. And that's because they feel they have this relationship that cuts through that fear and that threat. So even though that kid is looking at me like I have horns and I'm a monster, when they turn and see that other adult, even though they're so dysregulated, that other adult doesn't load up as a monster to their amygdala and their hindbrain. And so they're able to access that kid and meet them and then help them regulate. And so it's really fascinating that relationships end up becoming the largest part of this work. And that's one of the major things that I do when I'm helping districts and schools and professionals in the classroom, it's sort of an annoying thing, but really building a strong relationship is by far the best thing that we can do. Because when kids feel safe, they're willing to take more risks. They're willing to put themselves out there, and knowing that they could fail. Some of our brains are saying, why would I even bother to do that, right? I'd rather blow up and get kicked out of class than take a risk of reading out loud because I know I'm going to sound awful. But when they have that relationship and that safety and security, they can know that even though they sound awful, that they're still going to feel safe and loved and secure. And so that's part of some of the basic things that we can do, is just building those relationships. All right, I'm gonna wrap up there. Obviously, there's so much more to talk about, and I turned a half-hour presentation into an hour plus. But I appreciate you guys hanging with me. Definitely feel free to reach out and give me any feedback. I'll send out as soon as I can get the link up for you. Check out on our DOE site. There is a trauma-informed response and readiness page. If you go to the Office of School and Student Supports, which is my office, you'll see a sort of a graphic on the right-hand side that says trauma-informed response and readiness. And the slides and the notes are in there. Hopefully this video will be there shortly. So hopefully that helps. I'm gonna drop my email in here in case anybody has any questions. Oops, I did it privately. Hang on a sec. So feel free to reach out with any questions. Know that I'm going to post these up as soon as I can, and that we'll blast that out there. That's definitely the most requested question I get. And if you find my emails to be a little terse, I apologize. I'm getting hundreds of them, and so I'm trying to sort of mail them as much as I can. But please, any critique, I love hearing back things that you like, things that you don't particularly. They really help me make these things better. I'll be doing some open office hours for clinical mental health for school counselors and social workers next week. And I'm working with content areas on doing specific mental health supports for developmental and grade levels. So hopefully that'll be coming next week or soon after. And if there are specific areas you want to hear back from me, shoot me an email. I really appreciate it. So thank you all so much. Have a great weekend. Hey, check out Kelly Bailey and I have been doing sort of bookend staff supports. So in the morning, she's doing at 8:30, she's doing some just brain based like centering and breathing. And then I'm trying to do the same thing at 3:30 at the end of the day. It's really just to provide some like place that we can all be together and breathe and check in and get some of that support. We're all carrying a ton of weight right now, and particularly being those essential people for our kids, and knowing that we don't have the same sort of access to them right now. We're already stressed out with all of our families and ourselves, so we carry a heavier load with all those kids too. So find ways of getting support for that, and if those bookended support sessions help, please join them and check them out. So have a great weekend. It was great talking to you all, and hopefully I'll see you in some of mine next week. Thanks.